Hi, I'm Rick Croslin. I am a member of the Academy of Model Aeronautics. For several years, the Academy has been an active partner with the Alcoa Foundation to help teach science, technology, engineering, and math, what educators call STEM. As an experienced classroom teacher and science supervisor in a public school district, I know how much teachers and students appreciate a good hands-on project, one that helps everyone understand important science concepts that are part of the district's education objectives as well as state and national standards. One of the new programs we've developed with support from the Foundation is this Flight Research Kit. This science and engineering kit is designed so you can make a classroom presentation and share your work at Alcoa. And it helps teachers who wish to add a fun science activity to their teaching. The activity teaches the basics of flight and how Newton's third law, the push and pull of forces, helps keep an aircraft in the air. You don't have to be an expert on flight or answer detailed questions about the science content. The classroom teacher and the video we have provided will take care of that. Also, I know from extensive experience as a summer camp director that this activity works well with any community group, where a hands-on activity will help kids understand basic principles of flight. Once you are familiar with how to assemble this little model, you are ready to contact the school district. As you know, a personal contact with someone in an institution is always best. You might start with the teachers and schools in your neighborhood near your company. A phone call or an email to the central office will get the project off the ground. Share with the school how this new Alcoa presentation can excite students and teachers to participate in STEM learning. The best news is that this project is a crowd pleaser. After extensive testing in hundreds of classrooms with thousands of students, we know that everyone loves this activity. It will make your job as an outside speaker extremely easy. As you introduce yourself, explain how you would like to come and talk about your work, and demonstrate how the Wright brothers learned how to control their first flight at Kitty Hawk using an aluminum engine block donated by Alcoa. Today, many of Alcoa's facilities create products that keep airplanes flying. Even if your work and your plant does not directly produce aviation products, many company facilities continue to make major contributions to the aerospace industry, something we can all be proud of. When you visit a classroom, bring a simple outline of what you want to do. We've provided one in the kit for you. After briefly discussing your work at Alcoa, and if appropriate, the importance of STEM to your work, show the teacher the FPG-9 and describe the activity as an example of Alcoa's interest in supporting the study in the STEM disciplines. Explain that you will help students assemble the plane and have them make a few test flights to demonstrate how to trim it properly using the control surfaces. So let's get started. You're going to share this simple model airplane that has the power to engage every student, and it's as easy as 1, 2, 3. Step 1. Share a few details of your work experience with the students. What do you do? How you use science, technology, engineering, and math, as well as communication skills every day in your job. Step 2. Share the model. Introduce the FPG-9 as one example of how the Wright brothers discovered the secrets of control. This will get everyone's attention. Explain how a model airplane is used to help solve the challenges of flight. Today, NASA and aircraft manufacturers still use models to test ideas before building full-size aircraft. Tell the group that today they are going to have a chance to test the dynamics of flight. Step 3. Tell the students we are going to assemble a special model airplane with control surfaces. It's called the FPG-9, and it gets its name from the foam picnic plate commonly found in convenience and grocery stores. They will build and use the airplane to investigate how aircraft use control surfaces to climb, turn, and maintain stable flight. The completed FPG-9 consists of 2 foam pieces, a pre-cut wing and a fin or tail. The wing and the tail each have slits cut into them. You can score this with your finger or even use an ink pen to score this right here. Gently bend the elevons up and down to provide pitch and roll control. These control surfaces demonstrate how the push and pull of forces Newton's third law, helps control the glider. Demonstrate how to locate the cuts for the rudder on the vertical fin or the tail of the glider. Gently score the foam between the two slits so the rudder can be bent left and right to yaw the model. Now is the best time to have students put their name on the glider, making it possible to identify it later. It also helps to mark an arrow on the wing to indicate the direction of the flight of the model. Demonstrate how to slide the slit on the fin into the slit on the wing for a snug fit. You might have to have some adjustment on these because right now, when you put these two together, they kind of fall over, and that's not good. So what you should do is widen the slot just a little bit. Perfect. Use 4 small pieces of masking tape to secure the fin to the top and the bottom of the wing. Make sure the fin is perpendicular to the wing before adding tape. In order to make the plane fly successfully, the students must attach a penny on the top of the wing, right behind the square tab. Demonstrate how to fold the tab back over the coin and secure it in place with the Alcoa sticker. This step adds weight to the front of the plane, moving its center of gravity forward, giving it stability for longer flights. The FPG-9 glider is now ready to fly. The first step in flying the glider is to make sure it's trimmed to fly in a straight path. Instruct students to hold the glider at eye level and gently toss the plane out in front of them, pointed slightly down. Usually a little up elevon on each wing is necessary to obtain a long level flight. After students observe how the glider flies, instruct them to make small adjustments on the elevons and the rudder until the glider flies in a straight path. A small 1/16 of an inch change in these control surfaces is usually a major adjustment. Repeat the flight and observe how the glider moves through the air. Students may need 3 or more test flights to trim their glider to fly in a straight path. At this point, you'll be very close to running out of time for a typical classroom visit. So in closing, don't forget to remind everyone that this activity is science at its best, a chance to assemble, test fly, and even modify a model aircraft. You'll love doing this activity, and so will everyone you share it with. For more information about how to extend the lesson using other simple models, contact the Academy of Model Aeronautics Education Program using this link. The Academy of Model Aeronautics has many projects to share. The AMA can help you find local club members who can present high-tech demonstration flights of just about any type of model aircraft, from helicopters to tiny aerobatic airplanes that can be flown in the gym or outside. STEM, science, technology, engineering, and math make all of this possible. Alcoa and we at the Academy of Model Aeronautics love to share our passion for science with everyone.